Today's lesson is going to be on partial fraction decomposition. In your textbook, this is chapter 7.4. In fact, this is the only section of chapter 7 that we're going to be doing this year. Partial fraction decomposition reverses a process that you learned in Algebra 2 or maybe even Algebra 1. It reverses this process. What if you were asked to add 2 over x minus 3 and negative 1 over x plus 2? This was an Algebra 2 topic, or like I said, maybe even Algebra 1. If you want to shut the video off right now and see if you can simplify this expression, you can go ahead. Or if you want to just listen to me review this with you right now, you can. So the first thing you're going to do is find an LCD, and the LCD is these two denominators multiplied together, which is x minus 3 times x plus 2. And when you find the LCD, you have to multiply each one of these fractions by the opposite one. So this one you'd have to multiply by x plus 2 over x plus 2. Now the first fraction has the LCD. Multiply the second fraction by x minus 3 over x minus 3. And now the second fraction has the LCD. So if you wanted to distribute the 2x plus 4, distribute the negative 1, negative x plus 3, and then the LCD is x minus 3 times x plus 2. And then if you FOILed that together, you'd get x squared minus x minus 6. And then if you combine like terms, you just get x plus 7 in the numerator and x squared minus x minus 6. So that's what you did in Algebra 2. And now this year what we're going to do is we're going to take this fraction or any rational expression and we're going to perform a partial fraction decomposition on it, which just means break this fraction up into its two components. And the two components were what the original fractions were that I gave you. All right, so what we're doing is we are writing a rational expression like x plus 7 over x squared minus x minus 6 into the sum of simpler fractions. Okay, and when we write that rational expression as the sum of two simpler fractions, two or more simple fractions, that method is known as partial fraction decomposition. So there's about a three or four step method to do a partial fraction decomposition on a given rational expression. So to do a partial fraction, decomp, I call it a decomp. The first thing you're going to do is you're going to factor the denominator completely. Okay, so let's say we're given this. So what we're going to do is we're going to say x plus 7 all over. If you factored that, you would get x minus 3 times x plus 2. Okay, and then you're going to split like this. You're going to put some numerator, and we're going to call it the letter A, over the first factor, and another numerator, we'll call it B, and put it over the second factor. So what we're going to get is we're going to get our given fraction, x plus 7 over x minus 3 times x plus 2. That's what we were given, except we've factored the denominator. And we're going to split it. And we're going to put a capital A because we don't know what that's going to be. all over the two factors, the first factor as x minus 3, and then we're going to call the second fraction the letter b, and we're going to put that over the second factor of the denominator. So a and b are going to be constants, or in other words, undetermined coefficients. I'll call them constants, though. I've seen some books write them as undetermined coefficients. Okay, so that's the first step. After you get done splitting the fraction, then the next step is to multiply both sides by the LCD to clear the fraction. Or to clear the denominators. So if I take this given equation up here that I just wrote, and the LCD is x minus 3 times x plus 2, so if I multiply this by x minus 3 times x plus 2, whatever I do to the left side of the equation, I can do the same thing to the right side of the equation. So I'm going to multiply this by x minus 3 times x plus 2 and multiply this by x minus 3 times x plus 2. And if you remember from Algebra 2 last year, this was the method that we used to solve fractional equations. So to clear the denominator, this x minus 3 will cancel, this x plus 2 will cancel, and what we'll be left with is just an x plus 7 equals, and then these x minus 3's will cancel out, and we're going to be left with a times x plus 2. And over here, the x plus 2's will be canceling out, so we'll be left with a plus b times x minus 3. So what we're going to do is we're going to solve this equation for a and b. And there's a couple of different methods to do this, but I think the easiest method is, this is going to be true for all values of x. So since it's true for all x, we can let x equal any number that we want. And if we're tricky about this, we can let x equal a number that will make this factor go away. And when this factor goes away or goes to 0, then all we'll be left with is the b part of this equation, and we can solve it for b. So watch this trick. So let's let x be equal to -2 so that this factor goes to 0. If we let x equal -2 and we substitute it into the equation, we get -2 plus 7 here is equal to a times -2 plus 2, which is 0. I chose -2 to make this go to 0, plus b times -2 minus 3. I just substituted any value I wanted in for x. -2 will work very nicely because this will give us 5. This will give us 0 times a, which is 0. And then this will give us -5 times b. So if you divide both sides by -5, you get b is equal to -1. And since b is equal to -1, we can put a -1 in here and we can solve this equation for a, or we can be tricky like we did the last, like we did here, and then we can let x equal 3. So let's say now let's let x equal 3, so this factor will go to 0. And so when we substitute 3 into this equation, we get 3 plus 7 is equal to a times 3 plus 2 plus b times 3 minus 3, which is just 0, which will go away. And we get 10 is equal to 5a. So if you divide both sides by 5, you get 2 equals a. So we've solved for the constants. And now the step 3, the last step, is just to put the a and b constants into the split equation that we got from step 1. Okay, so a is equal to 2. So we go up here and we just call this 2 over x minus 3 plus b was equal to negative 1. So you put negative 1 in for this capital B, and we get negative 1 over x plus 2. And that's the partial fraction decomposition. That is equal to what I originally gave you as a problem to solve or to decompose. X plus 7 over x squared minus x minus 6. And we've already done this addition from the very beginning, so we know this is the partial fraction decomposition, this part of it. So we call that partial fraction decomp. And we're done with that problem. So the only thing left to do now is to practice for a couple more problems. I'll give you one or two. I'll go over it with you, and then maybe I'll give you one to do on your own, and we can talk about it tomorrow in class. So let's look at another example. Let's say our example here is find the partial fraction decomposition for 2 over x squared minus 1. That's the only instruction we have. Find the partial decomposition for that. All right, so step 1 says we're going to factor the denominator completely. So we have 2 over x plus 1 times x minus 1. And then we're going to set it up with a capital A over the first denominator, which is x plus 1, and a capital B over the second factor, which is x minus 1. The LCD is x plus 1 times x minus 1, so you're going to multiply it by x plus 1 times x minus 1, x plus 1 times x minus 1, x plus 1 times x minus 1. And you'll see a really easy pattern after a while. You'll just learn that this whole denominator is going to always go away. So you're going to be left with, on step 2, after we cleared the fraction out, we're going to be left with just a 2 on the left, and we're going to be left with a times the denominator of the other fraction plus b times the denominator of the first fraction. Okay, and if we let x equal positive 1, we get 2 is equal to 0 times a plus 2b. And if 2b equals 2, then b is equal to 1. And now we're going to let x equal negative 1 so we can solve it for a. And we get 2 is equal to a times negative 1 minus 1 plus b times 0, which is just going to go away. So we get 2 is equal to negative 2a, which says a is equal to negative 1. So the partial fraction decomposition is putting this a over this denominator, which is negative 1 over x plus 1, and then b over this fraction, positive 1 over x minus 1. So that's the partial fraction decomposition. That's the final answer. And if you wanted to check your answer, all you'd have to do is get the, like you did in Algebra 2, you get the LCD and simplify the fraction. and you should come up with that partial fraction decomposition. And we'll just do one more example together, and I could give you one or two to do on your own. So here's your next example. Let's say we have 5x minus 1 all over x squared minus 2x minus 15. And our instructions are to find the partial fraction decomposition of that. Step 1 says we put in a, oh well, we have to factor this, and this factored is x minus 5 times x plus 3. So we put the a over the x minus 5, we put the b over the x plus 3, and it doesn't have to go in this order, of course. You could have put the a over the x plus 3 if you factored it the other way around, but in the end you'll get the same answer. All right, when we clear the denominator, this denominator goes away, and we get 5x minus 1 is equal to, you're going to multiply a by this other denominator, a times x plus 3, and multiply b by this denominator, b times x minus 5. So that's the equation we're going to use to solve for a and b. So if we let x equal negative 3, that'll go away. So we have 5 times negative 3 minus 1 is equal to 0. I'll just put a 0 in because I've done it so many times. I know this is going to 0, plus b times negative 3 minus 5. See, this is negative 15 minus 1, which is negative 16, and negative 3 minus 5 is negative 8, and divide both sides by negative 8, and you get b is equal to 2. And now let's let x equal positive 5, so that will go away, and we get 5 times 5 minus 1 is equal to a times 5 plus 3 plus 0, because I know that's going away. So this is 25 minus 1, which is 24, and 5 and 3 is 8. A, so divide both sides by 8, and you get a is equal to 3. So the partial fraction decomposition in the end is 3 over x minus 5, because you put the a here, 3 over x minus 5, plus 2 over x plus 3. And if you wanted to check that out, and like you did in Algebra 2, just add those two together, that should give you a 5x minus 1 over x squared minus 2x minus 15. Now this is called case 1. We're going to be studying 3 different cases of partial fraction decomposition. So let's see, where can we put this? I guess we'll put this down here. Or these were examples of case 1 out of 3 where the denominator has unique, or in other words, distinct, linear factors. And if you notice, these factors are all linear. Linear means x is just raised to the first power. X minus 5 is a linear function. X plus 3 is a linear function. X plus 1, x minus 1, they're all linear factors. So sometimes these factors aren't linear. Sometimes they're quadratic, or sometimes they're not distinct. Sometimes they're not unique. Sometimes they're repeated. And so that would be case 2 or case 3. I'm going to get into case 2 and case 3 in tomorrow night's video, but just know that this is just the first of 3 cases, which is not too bad. So if you wanted to try a couple on your own for tonight, and then I'll just give you the solution tomorrow, I'll just say you try to decompose 3x minus 25 all over x squared plus 2x minus 15. And if you want to try a second one on your own, you can try 7x minus 1 over x squared minus 1. That sounds familiar. Is that the one we just, no, that's a different one. So here's two different partial fraction decompositions. The denominators are similar to a couple that the two that we just did, but they have different answers than what we just got. So if you want to try those, go ahead and we can talk about the solutions tomorrow.